Greetings, my name is KODURU, bearing the roll number 23211A05R8 from the section CSCE, and in compiler design I'll be presenting on the topic type checking from Unit 4. The topics that are going to be discussed are type checking, conversion, types of type checking, benefits, design and position of type checker in compiler, and overloading. Now let's start with the main point, which is what is type checking? Type checking is the process of verifying and enforcing constraints of types in values. A compiler must check that the source program should follow the syntactic and semantic conventions of the source language, and it should also check the type rules of the language. So, what these two statement means is that type checking is the process of ensuring that a block of code or a block of text or a part of language follows a basic constraint or the rules that are laid out by the language. Like it should follow the basic schema and the structure or the language which it is going to be analyzing. Now, it allows the programmer to limit what types may be used in certain circumstances and assign types to the values. The type checker determines whether these values are used appropriately or not. So it also ensures and it also sees through it that the values that are being used are appropriate or not in regard to the basic structure and the content of the code block. It checks the type of objects and reports a type error in case of a violation, and incorrect types are corrected. Whether the compiler we use while it is compiling the program, it has to follow the certain types of rules of the language. Every language has its own set of type rules for the language. We know that information about data types is maintained and computed by the compiler. Uh, this is the same as what I have already said. Now, uh, to understand this, let's go through some conversions. Process of converting from one type to another type. There are basically two types, as in major languages. Programming languages such as implicit and explicit. Implicit conversion refers to conversion of one type to another type, which is done automatically by the compiler. Now, implicit type conversions are also called as coercion. And this coercion, which is implicit type conversion, is limited in many languages. Like the power of this type of conversion is pretty limited. And let's take an example. An integer may be converted to a real, but a real is not converted to an integer. Okay. Now the conversion is said to be explicit if the programmer writes something to do the conversion. As it's pretty nameworthy, explicit, external. So a programmer is external to the program, hence the name explicit. Now let's go through the implicit type conversion example. Here we are given a pretty small code block, which is int number equals to 34.78. As we know, int refers to integer, and here 34.78 is a double value. It's a decimal. So integer only gives out 34 and removes the like dot and after values are negated. Hence the output would be 34, which is as per the compiler. Now moving on to explicit type. In explicit type conversion, we manually convert values of one data type to another type. For example, integer number equals to 35, printf. Integer value, this is basic again programming block. Here we are given int, a number equals to 35, which is in accordance to the integer. Now we want to convert this int value to double. So the programmer, which is us, will give a double value equals to double of number. Number here is an integer variable. So by this way, we can convert the integer value to the double value. So we get the double value equals to 34.00. Now, moving on to the third topic, which is types of type checking. There are two kinds of type checking, primarily static type checking and secondary dynamic type checking. Static type checking. It is defined as type checking performed at compile time. Yeah, so it's pretty noteworthy. This is the type of type checking that is done at, performed at compile time, and whereas dynamic type checking is performed at runtime. Okay, and moving over to the next point, it checks the type variables at the compile time, which means the type of a variable is only known at the compile time. It generally examines the program text during the translation of the program. Uh, it's already given over there. So when translating from one language to another language, that's when the process of type checking occurs and errors are found out and modified. Using the type rules of a system, a compiler can infer from the source text that the function will be applied to an operand, let's say A, of the right type each time the function fun of A is evaluated. As I've said before, during the compile time, it will go through the block of code, and when there is an error, it will identify the error and modify the error. Now, examples of static checks include there are four types, which is type checks. Second is flow of control checks, uniqueness, and name related. Now, type check refers to a compiler should report an error if an operator is applied to an incompatible operand. For example, if an array variable and function variable are added together, that's when this occurs. And now coming to the second one, which is flow of control. Statements that cause the flow of control to leave a construct must have some way, somewhat of a place to return true, like when the flow of transfer shifts from one control to another, that is when this occurs. For example, a break statement in a C or any language causes control to leave the smallest enclosing while for or switch statement. Like we use it to exit the loop. If we don't use it, then an error might occur. That's what this refers to. And now moving on to the third one, which is uniqueness check. There are situations in which an object must be defined exclusively, uniquely, like only once. For example, in Pascal, an identifier must be declared uniquely. Now, moving over to the fourth point, which is name related checks. Sometimes the same name may appear twice or thrice. For example, in case of AMAR, my name, a loop may have a name that appears at the beginning and at the end of the construct. The compiler must check that the same name is used at both places. Like my name can't vary, right? If it varies, then the program, like the construct would be different overall. Now, let's go through the benefits of static type checking. There is no explanation for it. It is pretty self-explanatory. First point is runtime error protection. Okay. Because as I said, static type checking is like compile time based off. So it protects us from runtime, obviously. It catches syntactic errors like extra punctuation. It also catches wrong names. It detects incorrect argument types. It catches the wrong number of arguments. It catches wrong return type, like return 70 from a function that has to accept a value of like an integer. Dynamic type checking. Now, moving over to the second type of type checking, which is dynamic type checking. As I've already said before, dynamic type checking is done during runtime. It also associates itself with values, not variables, whereas the preliminary one is based off variables, whereas dynamic one is based off values. Now, implementation of dynamic type check languages are generally associated with each other through a type tag. Type tag is a keyword over here. Now, moving over to the second statement, dynamic typing is more flexible. Yes, it is indeed flexible because when we go over to static type checking, like it is pretty restrictive of the amount of commands or amount of ways in which you can express yourself in a programming construct. So dynamic typing, like it ensures that the compact programs are made flexible through various means, like like to say the least, in static type systems, the program is pretty gritty and implementation effort is widely needed. Now let's go over to the design of type checker depends on. Hmm. These are direct points, not explanatory. Syntactic structure of language constructs, the expressions of the language, the rules for assigning types to construct, basically the semantic rules. Now, the position of type checker in a compiler. As we've known, in the phases of compiler, each phase goes through an like testing or like checking phase. But let's go through that uh, because our unit is ICG, Intermediate Code Generator. Now, token streams over here, token stream. They are basically the output of lexical analyzer phase, gives out token streams, and these token streams are taken as input for the parser. So the parser, or let's say the syntactical analysis phase, uh, produces an output which is syntax tree. The syntax tree goes through the type checker. Type checker would again analyze the given syntax tree and make sure that the syntax tree format, or let's say the data types, or let's say the words or the naming conventions, is everything as per the order. And if there is any mistake, it would identify the mistake and it would modify the mistake. Later, it will give out another syntax tree. If there are no errors, then it will directly pass over the syntax tree from the parser to intermediate code generator without any major upgrades. Now, the output of intermediate code generator is intermediate representation of the code. Uh, this both paras are what I've already explained. The token streams from the lexical analyzer are passed to the parser, and yeah, it's pretty much the same. Now let's talk about overloading. An overloading symbol is one that has different operations depending on its context. Overloading is of two types: operator overloading and function overloading. Uh, Overloading is a concept which is widely used in like programming languages. Overloading occurs when one operation has specific functions. Like in programs too, there are various types of overloading: method overloading, constructor overloading, mm, class. No, 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 not class. Method overloading, constructor overloading. Yeah, as function overloading. Overriding, that's a completely different concept. But coming to operator overloading in compiler design, what it basically refers to is when there are arithmetic expressions, I mean, such as x plus y. Here, the plus is an operator, x and y are operands. Let's suppose x and y are integers. In another case, x and y are real numbers, and in another case, they are mm, some other number like double or something. So what occurs is the operator is the same, but the values differ from one and another. That basically causes operator overloading. And moving on to function overloading, it's also pretty self-explanatory. So what type checking like this phase does is Uh, it would solve function overloading by analyzing the number of arguments and also the numbers. Like based on the numbers and the arguments, it would solve the function overloading. That's it from my end and for my presentation. Thank you. And your host, Sayama Koduru, signing off.